So in this video today, we're going to be talking about the basics of Lewis dot structures. So starting out, Lewis dot structures were invented and named after the American chemist named Gilbert N. Lewis. So something that I would love to point out to you guys just for a little bit of perspective, let's move that, is the date that he died. So he died in 1946. So it's only about 75 years ago. So chemistry has come a long way in the past 100 years. That's really kind of been one of the newer versions of science. And so it's important to know that what you guys are learning now, it's not something that's been around for forever or uh, just even the most simple concepts or anything, but these are very new and very interesting and still very relevant things to study in the real world. And so when we're talking about Lewis dot structures, we only use our valence electrons. So that's important to remember. So even if we have a molecule that actually has, say, 53 electrons, we're only going to show the valence electrons, or those on the outside. And those are going to be drawn on four sides of the chemical symbol. Okay, and then additionally, in order to get those dots and know how many valence electrons you have, you can use the group number on the periodic table to tell you the number of valence electrons. So for example, if you're in group 1A, which is labeled at the top of the periodic table, you'll have one valence electron. So the 1 dot matches the 1 in the group number. It would look like something like this, where you have hydrogen with 1 dot, and remember that this 1 dot can be on any of the four sides. Okay, and then additionally, it's the same with group 4A. You have 4 dots in group 4. So you'll spread these dots out, 1 on each side before you start doubling up. So carbon will have 1 dot on each side to represent 1 valence electron on each side. Okay, and then as another example, group 7 would have 7 dots. So as a little bit of a practice, let's do maybe something that has 6 dots. So group 6, or it's also called group 16 or 6A, but overall it's got 6 valence electrons. So for example, oxygen is the top one on here. So in order to fill out our dots here, we have 6 valence electrons. So we're going to do 1 dot on each side and keep going, and then double up once we have to start doubling up. So we do 1 dot on each side. So, but we're only at 4. So we'll double up and keep going and keep adding until we have 6. So now we have 6 valence electrons around it. So 2 that are paired, or 4 overall that are paired, so 2 different pairs, and then 2 open or single electrons there. So this is a periodic table for you guys to look at. We're not going to talk in this course about the valence electrons or bonding for the transition metals. However, we should look at the main group elements, such as this group 1A or 1 has 1 valence electron. Group 2 or 2A has 2 valence electrons. Group 3 over here has 3 valence electrons. And then we keep going. So 4 is going to have 4 valence electrons, or 14. So 4 or 14, 4A or 14 will all have 4 valence electrons. 5, 15 or 5A will have 5 valence electrons. 16 or 6A will have 6. 17 or 7A will have 7. And then one thing that's a little bit funky that we need to pay attention to is everything below helium in group 18 is going to have 8 valence electrons. So helium itself, there's not quite enough room, so we're going to write it down here. Helium is going to have 2 valence electrons because it does not have enough room to have a full octet. It's going to only have those 2. Okay. And continuing on, talking about Lewis dot structures. So what is a Lewis dot structure? It shows each atom and its position in the chemical structure. So when you have water, for example, it shows that oxygen is in the middle and there's 2 hydrogens on either side. Shared pairs of electrons are covalent bonds, as we've talked about in previous videos. Lines are drawn between atoms that are covalently bonded to one another. So that line corresponds to the covalent bond, which also corresponds to 2 electrons. Excess electrons that are not shared are called lone pairs and placed next to atoms. So for example, if we have water, we have 2 lone pairs in a water molecule. So that's what they would look like. Okay, so let's look at an example of hydrogen. We would have, if we had a molecule of H2 or hydrogen gas, we would draw out 2 hydrogens with their valence electrons. So we have 1 hydrogen here with its 1 valence electron and a second hydrogen with its valence electron. Then, in order to show the covalent bond, this 1 electron from the green hydrogen and 1 electron from the red hydrogen are going to be shared in a covalent bond. That bond is then represented by this line here. And this would be your overall Lewis dot structure for H2. Another example, if we had F2, so now we have 2 fluorine atoms, we draw each Lewis or each fluorine separate with its own number of valence electrons. Okay, so we're going to have our blue one this time. It doesn't look very blue, but I promise it's blue. And then we'll have orange. So I'm only highlighting the 1 electron that is going to turn into our covalent bond in this case. So each fluorine is going to want to share 1 of its electrons with the other fluorine to make a covalent bond and to fill its octet role. So we make 1 of those each there. And then from there, we'll draw a line and represent our fluorine F2 atom or molecule as this Lewis dot structure here. So something that we could do to double check that our Lewis dot structure is correct is we're going to check to see if each fluorine or each atom in the molecule follows the octet rule. So in this case, we have 6 electrons on each fluorine from lone pairs. And then we have 2 electrons from our covalent bond. And together, when you add these, it's 8 electrons for each fluorine, which fulfills the octet rule. Okay, so let's do a practice, 2 practice molecules. We'll have HF and I2. So let's start with the first one, HF. So I'm going to draw each atom separate with its number of valence electrons. So hydrogen is in group 1, so it has 1 valence electron. And then fluorine is in group 7. It's going to have 7 valence electrons, so I'll draw 1 on each side, 3, 4, and then I'll start doubling, 5, 6, 7. Okay, and then we're going to draw a bond between the 2 electrons that are going to be covalently shared. And that will then give us our molecule, or our Lewis dot structure, HF. And then we're going to keep all of our lone pairs in our structure. So here is our answer for HF. And to check this, let's make sure everything follows the octet rule. So fluorine first, again, we have 6 electrons in a lone pair, and then 2 electrons in a covalent bond. So its octet rule is fulfilled. And then for hydrogen, hydrogen is the exception, so we only need 2 electrons, and it has 2 electrons in its covalent bond. So this follows the octet rule. Okay, so now let's try I2. So we're going to draw 2 atoms of iodine with each of their number of valence electrons. This time, because I know where the bond's going to go, I'm going to draw my single electron closer to the atom that I'm going to bind it to. So we have 1 here, and then let's draw a second one. And then I'm going to draw, I like to circle where the bond is going to be so that I know everything's accounted for. And then let's draw our final Lewis dot structure. So that would be our final answer. Let's just double check. It's symmetric, so we only have to check 1. And we have 3 lone pairs accounting for 6 electrons, and then 2 electrons in a covalent bond. So we do have our full octet. That's where this video is going to end, and I'll see you guys in the next one.